Hey guys, welcome back to part, I think this is part 4, isn't it? Right, we're going to be mainly talking about cylinders and pistons in this one and doing piston skirt to cylinder wall clearance measurements, but I just thought I'd add this little bit to this video about cylinder heads, and it's kind of a top tip really, which will save you a bit of time if you're doing one yourself. So as you know, this cylinder head has had its guides and its seats cut. Because it's had its seats cut, obviously all the original valve clearances are all going to be way off. So the story is, doing the valve clearances when you've had your seats cut can be a little bit of a pain in the arse, because depending on how much they've taken off the seat, you can end up with a zero clearance, which means when the cam is in and you bolt everything up, there's no clearance. You can't get the shim bucket to rotate. And then you've basically got to take it all apart again, put a slightly smaller shim in, get to a point where you can actually take a measurement, and then take it all apart again, and then work out what shim size you need. So there's a lot of, what I'm saying is there's a lot of taking apart and putting back together. Now you could do this with the engine assembled, with the cam chain on, and the engine all together. Doing it that way means you've got to fight constantly. Every time you take the cams out and put them back in again, you've got a constant fight with valve timing, clearly. So top tip for you, you can do it without having the head attached to the rest of the engine and without the cam chain. So you can literally just use a little bit of assembly lube just across the bearing journals and the shim buckets, rest the cam in, you can bosh that down, tighten it up really easily. You haven't got to fight with valve timing or cam chain tensions or any of that gubbins. And then somewhere here, where is it? Sorry, I'm in the camera. What I've done with it, I've got a little plastic, it's like a tyre, I don't even know what it's from. It's like a tyre lever. And you can rotate this cam easily. And obviously the head's supported, so the valves open and close. Anyway, you get the idea. No need to have the cam chain on. And you can do the inlet and the exhaust side independent of one another. And then it's like 2 minutes, literally, take the cam in and out, pull the shim bucket out, new shim. You get the idea, rather than trying to do it on the engine and fighting every time it goes together with valve timing and stuff. So do that way. I just wanted to add that little bit because that'll save you. Everybody, or not everybody, but you would assume that the engine had to be together and you had to turn it with a cam chain. But it will, the cam will stay in position, surprisingly. You can always get the lobe in the right place, and because obviously, let's say we were doing this one, fucking hell Jimmy going on, let's say we were doing this one, number 4 that would be, 1, 2, 3, 4, let's say we were doing number 4 inlet, you'll find that one of the other cams is pushing the valves, the cam will stay in position is what I'm trying to tell you. You haven't got to sort of try and hold the cam and do the clearance. You can usually, well, you can always get the cam so it just stays in position while you do your clearance. Anyway, waffling. Right, so let me get all the parts, because all the bits are here. I'll talk you through what we've got. Everything's clean, ready to be assembled. And then I'm going to show you some measuring of the cylinder and talk about cylinder wall finishes, and we'll probably dive into piston ring material a little bit, and I'll just try and add as much value as I can, as quickly as I can, without going on too much. Right, I'll show you the parts next. Right, so quickly show you what's going on with parts. Obviously it's not all here because some of it's already been used, so the guides, the valves, obviously, the 8 inlet, 8 exhaust, all the valve collets, they've already been used. So we've got new cam chain tensioner blade and guide blade for the cam chain, so the sort of valve train sorted out there. Some gearbox bearings, an input gearbox bearing, that's the main one behind the clutch, and then the output shaft bearing, which is the one by the front sprocket with the main oil seal for there. There's a thrust washer there for the clutch, which is the little one that pushes in the clutch basket. New clutch basket nut. We've got 8, they're the same, yeah, we've got 8 big end bolts, so the bolts for the caps on the conrods, various oil seals and washers and stuff, obviously piston rings, and what's in there, oh, piston circlips. And then Suzuki are awesome because they do a full gasket set. A lot of manufacturers, you've got to buy all the gaskets individually. So when you're doing an engine, you've got to trawl through all the bloody parts fiches, picking out all the part numbers, and it's a fucking pain in the bum. But Suzuki, one part number, everything you need in one bag, which is fucking amazing. Right, so that's the bits. What was the other thing I wanted to mention? Oh, the oil pump. I think I mentioned it's going to have a new oil pump. Let's talk oil pumps. Let's move the camera. Right guys, so quickly about oil pumps. This is like take number fucking 5. I'm doing my own head in here trying to talk about this. So let me, this is the final take, and if I waffle on, you're just gonna have to bloody listen to it. Right, oil pumps. You've all seen how an oil pump works, I'm assuming. In fact, let me just rest this together and you can see how it works. So with an oil pump, you have an in and an out, an inlet and an outlet port, if you like, and then you've seen one of these work before, I'm sure, but I'm showing you, and if I'm teaching you to suck eggs, I apologise. So you can see how the volume of these compartments, if you like, is changing as the pump turns. So what's happening is it's drawing oil in through one of the ports and forcing it out of the other. Now then, if you read the workshop manual, they say inspect the pump, and if there's any scoring, replace the pump. Now, it's a bit of a broad brush really in terms of is it broken, isn't it broken, that. From my experience, you can get away with quite a lot of scoring inside one of these pumps. That actually looks worse, that on camera, than it actually feels with a finger. So what they're telling you inside in the workshop manual is, if there is any, they tell you to inspect this face here. Should we get that in focus? This face, and internally inside here, and then the sides and inside the casings, if there's any scoring. And what they're worried about is, as this is rotating and drawing oil from one side and forcing it into the other, that you'll lose pressure, if you see what I mean. If there's any, you know, it's like a piston in a cylinder. If there's a gap for the oil to squeeze past, then you'll lose pressure. But here's the reality. And by the way, I've got a second-hand pump for this. There is a little bit of scoring here. A new pump is, with the VAT, believe it or not, is £300 nearly in the UK, which is just bonkers. But I've managed to find a mint second-hand one for 50 quid. So anyway, so it's going to have, you could get, what I'm saying is you could get away with this, 100,000 mile, and this would be fine, and I'm going to tell you why, without going on too much. These pumps are massively overspec'd. With this engine ticking over, it's already blowing off the, where is it? The oil pressure release valve. This spring-loaded valve here, which fits inside the sump and pushes into one of the oil galleries. This is what regulates the oil pressure internally. With the engine ticking over, this is already blowing off pressure. The pumps are massively overspec'd, so with the engine running, this thing is shifting a massive amount of oil. You imagine all the, so there's the crankshaft here, so you imagine all the, it's not in focus, is it, that? You imagine all the oil clearances on the big ends and the main bearings all added up. What a sizable hole that would be. And then when you take into account there's also oil injectors spraying oil up onto the bottom of the cylinders for the pistons, all the oil clearances in the camshafts, it's also feeding oil to the gearbox. If you added up all those oil clearances, I don't know what you'd end up with, but you'd end up with quite a sizable hole, I would imagine. And this pump is able to maintain enough pressure at idle to force oil to all those things out of all those oil clearances, and also blow oil off on this pressure release valve. So they're massively overspec'd. So some slight, what I'm trying to, fucking hell, get to the point. The point I'm trying to get to is, tiny little bits of scoring inside this pump is nothing compared to one 5 thou oil clearance on a crank journal. Do you see what I'm saying? So it's not a deal breaker if there's a little bit of scoring in your oil pump. Anyway, fucking hell, I got there eventually. Hope that makes sense. Right, so on the bench here, I might as well keep filming. Can I take my focus lock off? So I've got everything. Hang on a minute, I'm going to do this freehand, which I don't normally do. So I've got everything laid out here on this bench. All the bits ready to, knock myself over with a tripod. So all the bits laid out here on the bench ready to go. I'm going to get the cylinders, which are here. I'll get these on the other bench, and we'll start doing some measuring and talking about piston skirt clearances and maybe piston rings a little bit and stuff like that. Right, okay, see you on the bench. Righto guys, I'm going to try and do this in one take, but I might have to, it's kind of difficult to organise the thoughts in my head. So kind of bear with me, and if I start waffling on, I'll put some edits in. Right, cylinders. Same as with the cylinder head, really. Kind of obvious stuff. Check for flatness. If there's anything glaringly obviously wrong, you get a feeler gauge and measure anyway. That's kind of old news to you, I'm sure. What I want to talk about to start with is cylinder wall finishes and how important they are. They seem to get, when you listen to people talking about engine building, it never seems to get mentioned, yet the finish on the cylinder wall is one of the most important factors in building an engine that will have good longevity in terms of whether it will burn oil or not. You know, get this wrong and in 5,000 miles you'll have a smoker. Get it right, and in the case of this engine, 98,000 miles, sports bike engine, there's no discernible wear in these cylinders, and it was, you know, no oil getting past the rings. So it's super important, the finish. So contrary to not popular belief, but what am I trying to say? I think this is the point where I put a cut in the video, isn't it? So you would be forgiven for thinking that cylinders should be smooth as possible. So you hear people talking about, oh, it's got a chrome bore, which means a plated cylinder, or Nickersill plated. I mean, there are other types of plating other than Nickersill, but Nickersill is, in fact, I think Suzuki were the pioneer of anyway, let's not do that. So you hear people talking about plated cylinders, or chrome bores, and you envisage in your brain a super shiny cylinder, and that's actually the last thing that you want. So the way to fucking hell, get to the point, for crying out loud. So the way to talk about this, I guess, is to say, so what's the ideal, what do you want from a cylinder? What's the ideal scenario you want? So you want it to be perfectly round with no ovality and no taper. And you want the surface finish to be what's called a plateaued finish. I'll put a diagram up on the screen in front of you. So a plateaued finish, imagine hills and valleys. So you have a valley, imagine a mountain, a pointy mountain, and then you chop the top off the mountain. So what that gives you, the finished surface of the cylinder, it should have cross hatching at about 45 degrees from horizontal. So you'll see when you take an engine that isn't worn out apart, you'll see the cross hatching in the cylinder wall. And what that does is, those little lines you can see, they're the valleys, and as the piston travels up and down in the cylinder, oil is spread in those crosshatch grooves. And if the crosshatch, oh fucking hell, Jim, if the crosshatch grooves are all even, so that at the right angle, it means that the oil is spread evenly around the cylinder wall, and the piston ring doesn't have a tendency to, if you had all the cross-hatching going in one direction, you'd have a tendency for the rings to rotate. So you don't, you have even cross-hatching all over the cylinder wall. And that cross-hatching, as the piston rings move up and down in the cylinder wall, the oil is trapped, probably isn't the right word, but the oil is contained in that groove. And then the plateaued, the flat surface, gives a bearing surface for the ring and the piston skirt to pass over. Does that make sense? Now, one of the reasons why engines burn oil, I don't want to go down a massive rabbit hole with this, but one of the reasons why engines burn oil when they get tired is they get glazed cylinders. So that glazing is, so the cross-hatching, the plateaued finish, basically gets polished away. So you end up with a super smooth surface. And what can also happen is the valley in that cross-hatched honed finish can get carbon build-up and varnish and all sorts of, you know, chemical deposits in it, and then it's polished by the rings going up and down. And what happens then is there's nowhere for the oil to go as the piston rings pass the valleys, if you like, and the rings will skate, they'll sort of aquaplane over the top of that oil, and you'll end up with oil in the combustion chamber, and anyway, you'll end up with an oil burner. You need a nice plateaued finish. Let's talk about honing for a second. So, two kind of types of honing that goes on with engines. You can have a rigid hone, and you'd use a rigid hone if you had a little bit of ovality. You wouldn't do it with a plated cylinder. What tends to happen with a plated cylinder is if there's ovality or taper in the bore, you get it replated. The plating is so thin. But let's say we were talking about an old CB750, and they can run massive skirt clearances without, you know, you can get away with honing out a little bit of taper out of a cylinder wall with an old, you know, an older engine, not so much with new stuff. So you'd have a rigid hone. Let's say you had a thou of ovality or half a thou of taper in an old CB750 engine. You'd use a rigid hone, which is a hone which has got fixed stones that are adjustable, and you can hone out the cylinder. You'd use it in a power hone tool. You've seen them being used, I'm sure. There's coolant spraying in and the hone goes up and down. Is that my kids crying, or is it somebody walking past? Somebody walking past. So you'd use a power hone to hone out some ovality. But in this instance, with an engine like this, where the bores, well, I'll show you the measuring, but the bores measure, they're perfectly round. There's no taper, there's no ovality. They're not out of spec in any way, but the surface finish was slightly glazed. So you would use what you call a flex hone. This is a flex hone. They come in all different sizes, depending on they're very specific. So there's a big one there. I forget what I got that for. Anyway, they come in specific sizes for the particular cylinder. This is the one for this cylinder, so they're slightly oversized. So when you use them, there's a little bit of pressure on the cylinder wall. Different materials. So silicon carbide is the normal material you use. Like this one, I forget, this is for an old, this is for a Honda fight. This is a small one, probably a 4-cylinder Honda engine. I've got 20 of these that I've collected over the years because they don't seem to wear out particularly. So you get the size and the material you want, and you end up keeping them forever. This is a silicon carbide one, which is the normal material you would use for cutting a normal steel liner. Now these cylinder walls are Nickel plated, as I think I just mentioned. So Nickel is nickel and silicon carbide, so they're plated with nickel, and in the nickel is a silicon carbide suspended in it. I don't understand the science, but it's basically what you're trying to cut is silicon carbide. You can't cut, so that the sill in Nickel is silicon carbide. You can't cut silicon carbide with silicon carbide, so you use aluminium oxide. So the two types of hone, aluminium oxide and silicon carbide. So you'd use silicon carbide for, sorry I'm going on, might be interesting to some of you. Silicon carbide for sort of, you know, your normal steel liners in the older stuff. And anything that's plated, you'd use an ali oxide hone. There's a bit of a technique to it. You just do it with a power drill. There's a knack to get in. I don't know whether it's going to come out that well on camera, but you can see the cross hatching is 45 degrees from horizontal. There's a little bit of a knack. You use just engine oil. You can buy from Flex Home, you can buy the special cutting oil, but you can just use engine oil. You just, yeah, there's a knack to it. The speed that you've got it going at, and the rate that you go up and down. And there's some techniques where you should always go, you know, all the way out of the cylinder when you finish, so the cross hatching goes anyway. I don't want to. It's not a lesson on how to hone something. And then another super important thing. Sorry, I'm banging on. Is after you've honed, all those little valleys. You know, we talked about the plateau and the valley. All those little valleys, are full of all kinds of rubbish. These cylinders need to be cleaned to within a fucking inch of their life. If you don't clean them properly and you leave all the rubbish, they can look fine, but they're probably not fine. So basically, boiling hot soapy water, I just use Fairy Liquid dish soap, and you scrub the cylinder walls. I've got some bottle brushes that fit down inside really well, so you can just scrub, boiling hot water, lots of soap, and then clean them all, rinse them all off, and then you think they're absolutely spotless, and then clean them again. And then as soon as they're clean, and you've used hot water so they dry instantly, as soon as they're dry, just a little bit of clean engine oil on your finger, smear it on the cylinder wall, and you're good to go. I think a lot of people don't clean the cylinders well enough after they've honed, and it's a little bit of a pet peeve of mine. Anyway, fuck me, I'm going on. So that's a little bit of a, I know I'm skating over it, but that's a little bit of an overview of honing. The two types of hones you'll see in a motorbike workshop: silicon carbide and aluminium oxide. Anyway, that's honing. These are all honed. I'm going to do some measuring in a minute and talk about piston skirt clearances. Sorry, I'm banging on and on, aren't I? Piston rings. Fucking hell. Right. What can we say about piston rings? I don't want to delve too deeply because I am absolutely not the expert on this, but just to give you a little bit of an overview, there are different materials available. Right, okay, piston rings. So back in the day, if you wanted a piston ring, it would be a cast iron piston ring. There wasn't really anything else available. There's lots more exotic materials these days. I can remember back in the day, I'm fucking aging myself now, but 30 years ago when I started as an apprentice, I can remember fucking horrible two-stroke cast iron fucking piston rings, and they were made of fucking glass. You'd be trying to stretch them over to get them in the ring gland, and fucking hell, they just break. If you looked at them the wrong way, you're trying to feed them on with a feeler gauge and stuff. Modern rings are way more durable than that. So what are they made of, piston rings? Well, ductile iron, which is a cast iron, but it's got magnesium in it apparently, so the clever people tell me. I say I'm not an expert at this, it's just what I've learned over the years. So ductile iron is one of the main materials used for piston rings, and then carbon steel as well, and it's usually got a nitride coating on the carbon steel ring. So these rings, I'm not 100% certain, but these are likely to be a carbon steel top ring, because the carbon steel is really good for, you know, it's a forged carbon steel, and it's good for strength and, you know, resisting damage from detonation and stuff. And then it's got a nitride coating, which makes it even harder again. So that would be the top ring, and then the second ring is likely a ductile iron, and they use a moly coating on the ductile iron rings, usually for wear resistance and stuff. It's a massive subject, piston rings, and I am, as I said, I'm massively not the expert, so go do some research if you're interested. There's loads of info out there, and loads of exotic materials and stuff depending on your application. But as far as I'm aware, this is a carbon steel top ring on this and a ductile iron with a moly coating on it, the second ring. So yeah, that's piston rings. These pistons, cleaning the pistons, they've been in the ultrasonic tank, got all the crud out of all the ring grooves. There's no wear at all. I could show you how to check for wear in these grooves, but there's no, in these ring lands, there's no point. You could break an old piece of piston ring and start measuring and stuff, but you can just immediately tell whether something's worn out or not. And these are basically still like brand new. Yeah, so they had a massive go in the ultrasonic tank to get all the carbon and all the crap out of them. And there's a little bit of carbon left on the piston crowns that was really stubborn. So the crown has just been in the vapor blast cabinet just really quickly. I wouldn't be vapor blasting skirts or anything. I know people will tell you that vapor blasting doesn't do anything to the material, but that's actually a lie. If you look at it really closely, it's basically peening the surface, which is why you get this nice shiny. Anyway, let's not go into that. Crowns have been vapor blasted. The rest of it's been ultrasonicked. Right, let's talk about, in fact, fucking hell, I need to go and have a sit down and have a cup of coffee. Let's do some, just quickly do some, I'll show you how I measure cylinders and piston skirt clearance and stuff. Right, onwards. Just watching that bit of a edit back. I didn't mention a couple of things. Piston rings, didn't mention the oil ring, of course, the oil control ring. Yeah. What did I want to say about piston rings? Contrary to popular belief, people say that the top two rings are compression rings and the bottom ring is the oil control ring. Actually, the top ring is the compression ring. The second ring is 80% also an oil control ring. I don't want to get massively into it, but I thought I'd just add that bit. So you've got the oil control ring, or the oil scraper ring as some people call it. That's getting rid of an awful lot of the oil, and there's also, I don't know if you can see these drillings in the ring. Fucking hell, don't want to get into it. But what I wanted to say was the second ring is also an oil scraper ring. The top ring is the compression ring. And then the other thing I didn't mention, where's me flex hones gone? I mentioned the materials, but I didn't mention the grit. So I use exclusively, I only have two grits of stones. When I do Nickersill, I always hone, and this is just what works for me. I'm sure other engine builders have got their own fucking theory on what works, but this is what I've always done. It's always served me well. I've never had oil burny engines coming back to me. When I do Nickersill, I do 240 grit. Everything else that isn't Nickersill, I do 180. And there's an argument for different ring materials need different blah blah blah, but that's what I use. I use 240 with the alloy oxide and 180 on the silicon carbide stuff. Anyway, right, I'm going to get that coffee and then we're going to do some measuring. Cool. Right then. So I've had a bit of lunch. I'm feeling a bit more refreshed now. So let's talk about, we've done cylinder wall finish. Let's talk about piston skirt clearance and cylinders. So what do we need from a cylinder? We need it to be round, not oval, and we need it to not have any taper in it. So I don't want this to turn into a how to use a micrometer and a bore gauge lesson. What to say about that? So I swapped from, sorry, getting in the shot, I swapped from analog to digital stuff a couple of years back, and it's been a blessing actually. I'll show you one of the most amazing things about having a digital bore gauge like this is you can instantly read piston skirt clearance wherever you like. I'll set it up and show you how that works, but first thing you would do, measure the pistoni. Let's move my brew out of the way. So it tells you in the workshop manual where to measure it, but it's just, I think they say 15 mil down from the bottom of the skirt there. 71969. I don't know what the spec is. I'll flash it up on the screen, but it's, I've already done them, but I did them, yeah, I did them a week ago. Long story. I know they're fine. This is just for the video. 71969. It's within spec. Here's the spec on the screen, what they should be. What I'm going to do now is I'm going to lock out this micrometer at that size. Now all the pistons are the same. There's about 5 to 10 microns difference between each piston, so we'll just use this as the reference if you like. So that is piston size. Now measuring the bores, so standard they're 72 I think. Yeah, let's do that. Let's measure the bores next. So how to show this best? So standard bore size is 72. I've got this calibrated to 72. So what I'm going to do is I'm going to hit the min button, okay, and I'm going to swipe this bore gauge in here and it will read off its minimum reading. So if we're seeing that, 72 and 16 microns, 72016. And then what we can do is just reset it, and we just go again, and we just keep taking measurements from different places in the cylinder, and we see, he says, we get very within a few microns. It actually doesn't matter where you do it in the cylinder. So we're getting very consistent readings. So we can immediately just bosh this down. We haven't got to mess around with the dial gauge. We can just put this anywhere in the cylinder, and then we can move along cylinders. So we know that they were all supposed to be 72 standard. We can move along the cylinders. Oh, didn't put me min on then. You get the idea. That's that one. They're all, I can tell you now, they're all, the maximum they're out is about 10 microns between each cylinder, regardless of where you measure them. Anyway, so that's that. So we know there's no taper, and we know there's no ovality. Now then, piston skirt clearance. Here's a cool little trick for you. Right, so here's the cool thing you can do when you've got a digital one of these, digital bore gauge, is I'm gonna, that's turned off, 71969, that's the piston size, that's what this is set to. What I'm gonna do is I'm gonna set this isn't a how to use a digital bore gauge, but I'm gonna set this so when it's reading, when this is reading 71969, this is 0. This is zeroed out. That way, when I put it in the bore and I do a min sweep with it, it will give me, I haven't got to do any calculation in my head, it will just read off the piston skirt clearance. Does that make sense? So do that, fast forward this bit. I'm sure there must be an easier way of zeroing out this thing, but I don't know what it is. If anybody knows, please tell me. Right. Okay. Okay, set. Right, okay, so do min. Do a sweep in here. Tangled up in my mic wire. It's hard with the camera in the way. Not sure you're getting this. Basically, calibrate it. So when I stick it back in here, within a micron. Right, over to the cylinder and I'll show you what's going on. Right, so what happens now, I hit the min button, I do a swipey. I know I'm measuring this way, not this way, it's just, I'm just trying to show you 37 microns. Actually, let me switch it, because my brain works in imperial, let me switch it to thou. Because I'm sure a lot of you will prefer to see in imperial. Okay, min, do another swipe. So we're measuring, this is just going to read off piston skirt clearance, 1.5 thou. Go again, let's do a proper reading this way. Oh, hang on, I didn't min it. Sorry, people. .5 thou. Go further down. 1.6. You get the idea. And go do the other cylinders, you'll see 1.45. You get the idea. Can you see that gauge on there? I think you can. Anyway, the cylinders are absolutely fucking perfect. How can they be this good after 98,000 miles? Anyway, that's a quick, tiny dive into measuring bores, for ovality, taper, getting your piston skirt clearance dialed in. Should probably mention at this point, ring end gap. Now, almost without exception, when you're building a bike engine, there's no dicking around filing ring end gap. The rings are not pre-gapped, because that ain't the right word. They're manufactured that way. The tolerances are so precise. If you've got the right piston skirt clearance, okay, and you're using genuine rings, you haven't got to measure the end gap. Trust me, it's fine. I'm not measuring it. It's definitely fine. So that kind of covers pistons and cylinders and stuff. Going to put these on the con rods, put the rings on them, put the rods on, the wrist pin, gudgeon pin, whatever you want to call it, depending on where you're from. There, I'm using the original ones. There's no visible sign of any wear at all. New circlips, new rings on here. So put the rod on, we're going to drop them in. There's no point in showing you this, it's old news, I'm sure, to most of you. You need a piston ring compressor, so you just oil them up and then push them in, and then we can flip this over. We can put the shells back in the crankcase. Shells are all out, obviously, because it's been vapor blasted and cleaned to within an inch of its life. There's some oil jets that need to go in the crankcase here. Put the shells in, and we can drop the crank in, and I'll show you a little bit of that as it goes together. A little bit of assembly lube on the shells, and then we'll talk about a little bit about torquing up big end caps, because there's some mistakes you can make there. Cool, I think that covers this. Let's actually start putting it together. Coolio. Righto guys, I think we're going to call time on part 4. I've already got way too much footage, I think, to try and keep this a short episode. So we'll continue the assembly in part 5. Thanks for watching.